Hello dear students of plus 2, medical, non-medical and respected teachers. Today I am going to discuss another topic from semiconductors, which is known as transistor as an oscillator. So first of all, what is an oscillator? An oscillator is a device which converts DC into AC, that is direct signal to alternating signal, and this device is used to produce carrier waves of desired frequency, which are used for communication, for radio communication. So that's why it is very important device. Now, to understand the working of this oscillator, how an oscillator works, so make the circuit diagram as shown in the figure. Basically, here we have antenna connected to inductor L2 and variable capacitor C1, and this is earthed. Here we have NPN transistor. This is input circuit, inductor L, capacitor C variable connected to base emitter battery, and this circuit is forward biased because it's NPN, so N2 negative, P2 positive. So this is basically known as tank circuit. And here we have key and DC source of supply voltage connected through inductor L1 to the collector. So this is the circuit diagram for transistor as an oscillator. Now how it works? Because it has to convert DC to AC. First of all, we start from here. Make the key K on. You insert the key K so that DC current starts flowing in the circuit. But as in this circuit, inductor L1 is connected. So when current grows through inductor, induced EMF is produced, self-induced EMF is produced, which opposes the growth of current. As a result, we can say increasing magnetic flux is linked with L1. And this increasing magnetic flux linked with L1 is also linked with inductor L2, because this inductor L1 and L, they are inductively coupled. That is due to mutual induction. Increasing magnetic flux linked with L1 is also linked with L. When flux through L increases, this capacitor starts charging, say with upper plate positive. When this capacitor charges, base emitter, so this forward voltage, forward bias increases as some potential difference set up across the capacitor. When forward bias increases, emitter current increases. Emitter current, which in turn increases the collector current to outer circuit. And when the collector current increases, more increasing magnetic flux is linked with L1. And this increasing magnetic flux L1 is also linked with L. That is, magnetic flux through L also increases, which further charges the capacitor. And again, emitter current increases, collector current increases, more flux is linked to the L1, and hence L and capacitor goes on charging. This process continues till this capacitor gets fully charged. When this capacitor gets fully charged, then this mutual induction between L and L1 is cut off for a moment. At that moment, this circuit becomes free. Capacitor is fully charged. Then capacitor starts discharging through L. As soon as capacitor starts discharging through this inductor, because this circuit is complete, this forward bias decreases. As a result, emitter current decreases. As a result, collector current decreases. And hence, decreasing magnetic flux is linked with L1, which further decreases the flux through L and further discharge the capacitor C and further decrease the forward bias, further decrease the emitter current and further decrease the collector current. And this process continues till the capacitor is fully discharged. And this process is repeated again and again. It means due to charging and discharging action of the capacitor, this tank circuit containing inductor L and capacitance C starts oscillating with a frequency of the order of nu is equal to 1.2 pi under root LC. This circuit starts oscillating. Now these oscillations are communicated to antenna through inductor L2 and variable capacitor C1. So we are adjusting the capacity when these two circuit frequency of these two circuit matches, that is at resonance. These oscillations from tank circuit are communicated to the antenna through inductor L2 and capacitor C1, and hence we get carrier waves, high frequency carrier waves from the antenna. So this is how an oscillator produces carrier waves which are used to transmit signal from one place to another place. So this working of oscillator is very, very important, and this type of output we get, which is AC, alternating signal, that is carrier wave. Why it is called carrier wave? Because it is used to carry the signal from one place to another place. So it is used for transmission, and the frequency nu is given by 1.2 pi under root LC. So it means junction transistor can be used as an oscillator to produce carrier waves of desired frequency. So we can produce carrier waves of desired frequency by adjusting the value of LC. So this is all about NPN transistor or PNP transistor as an oscillator. So this is how a transistor works as an oscillator. So thank you and stay tuned till next video. All the best, good luck, be happy and stay safe. Sarbat Dabala.